Hey y'all, it's your favorite Miss Harper here for factoring day 2. Alright, so if you missed this in class, what we did was we took our very important factor sheet, we just flipped it over and wrote down some examples on the back. So what this is pertaining to is if you look on the front side of your factoring sheet, it'll say there's those 3 questions at the top, and the first one says, is my quadratic in standard form? And second question says, is there a GCF? And third question is A equal 1 or is A greater than 1? So now it's going to be, we've been kind of skipping the first 2 questions and running straight to the third question, but now it's going to be really important that we run through each of those 3 questions every time. And we'll see some examples of why. Alright, so looking here at this first example, it says to take out a GCF first. So this is when we are about to start on a factoring problem and we read through our questions. We say first, are you in standard form? And we're like, yeah, that guy's in standard form. Second thing is there a GCF? Now, most of the time they don't always jump out at you. Sometimes they will. So it's really important that you take about 10 or 15 seconds to stare at this problem and say, is there a GCF? So remember, we look at our smallest number, 3. Does 3 divide nicely into our other 2 terms here? And the answer is yes. So we do have a GCF. Alright, so what I'm going to do is I'm going to first factor out that GCF by dividing everything by 3. And I'm going to have 3x squared divided by 3 is 1x squared. 12x divided by 3 is a positive 4x. And negative 15 divided by 3 is negative 5. Alright, and now look what kind of a quadratic function we have to play with now. It's one of our easy ones where a is equal to 1. Alright, so we kind of ignore this 3 out here on the outside for just a little bit, but I'm going to put him down here so I remember that he goes with my final answer. Alright, so I'm going to factor this thing as usual. I need it to multiply to a times c, which is 1 times negative 5. And I need it to add to b, which is 4. Alright, so 1 times 5 is going to be our guy. We need this to be a negative 1 and a positive 5. So here are those, x and a negative 1, x and a positive 5. Alright, so if I wanted to check myself real quick by distributing, I would end up at x squared plus 5x minus 1x minus 5. These two always combine. Minus 5. Alright, so does this take me back to my original equation? Well, no, because my original equation said 3x squared, blah, blah, blah. Alright, but it does take me right back to this part, which is good. This is my reminder that I have to keep this 3 out here in front. So at least it took me back to here, which is good. So that means I did get the right answer for this quadratic inside of here. So I'm going to throw that in here. Now if I FOILed or distributed, I'd get here. But then we'd have that extra 3 out in front, which would take us back to our original answer. So this is your final answer. So pretty much you do everything the same, except you take that GCF out first, do everything else the same, and then just make sure that your GCF is part of your final answer. Alright? Cool. Now, before I get started on this next example, not every problem is going to have a GCF. If you have a cute easy one, like where it says 1x squared plus 5x minus 3 or something, that one's not going to have a GCF. A GCF of a positive one is not going to count as a GCF in regards to what we're talking about right now. Alright, so looking here at our next problem, well, first of all, first question, is this in standard form? Well, let's remember, what does standard form look like? Alright, so something to the second power, then x, and then a number. So no, this thing is not in standard form. So I couldn't even factor this thing if I wanted to, which is why we have to take note and take out our GCF first. Alright, so what would be the GCF here? Again, what's the largest number I can divide out from each term? That would be a 3. And do they have anything else in common? Yes, this guy has 1k, he has 2, he has 3. The most I could take away is 1k. So I divide that 3k out from everybody. And I'd be left with 2k squared plus 5k plus 2. All right, and then again, I'm going to kind of ignore this 3k out here on the outside, but I do want to put him down here with my final answer so I don't forget him. All right, from here it's business as usual. I'm going to be looking right in here. A is greater than 1. So I do my A times C, which is 2 times 2. My B is 5. 1 times 4, 2 times 2. 1 and 4 is going to be our guy, and they both get to be positive this time. Alright, so again, kind of ignoring this 3k out here for just a little bit. I got this plus 2, got this 2k squared, and here's my starting point. Alright, so I just found my new factors, my missing pieces. Before he became a 5k, he was a positive 1k and a positive 4k. It's not actually necessary for this positive sign, but it's there. So, alright, so now from here, our next step is to take out the GCF. Our GCF in our first group of parentheses, a 1 and a k. So 1k, divide out that 1k. And we'll see what we're left over with on the insides. Our GCF over here is a 2. Divide out the 2, and we'll see what we're left over with on our insides. 2k squared divided by k would be 2k. 1k divided by 1k is just positive 1. Remember, anything divided by itself is just 1. 4k divided by 2 is 2k. And 2 divided by 2 is a positive 1 again. Here's our checkpoint. Do we have matching parentheses? Are they hashtag twinning? In which case they are. So these guys get to be one of our factors. And then the stuff on the outside will become our other factor. So we have a k and a positive 2. And then one of our twins was 2k plus 1. Now this would be my final answer. If I distributed this back, it would take me back to my very first original equation right here. Alright, so these ones just happen to have 3 factors now. Our GCF and then the other 2 normal parentheses, or other 2 normal factors. Alright, next one, here we go, special cases. Okay, so again, running through those questions. Is my quadratic in standard form? Well, doesn't this thing look a little weird? So let's go ahead and rewrite what is our standard form. Well, that is ax squared plus bx plus c. So which piece are we missing here? Well, hopefully you recognize that we are missing our b term. Now, why do you think we wouldn't have a b there? What do you think the value of b is that would cause him to disappear? 0 is your answer there. So all we do is we plug in a 0 and we handle it from here. So again, all I did was input that 0. So now I'm in standard form, and now I can go through our regular steps. All right. Luckily, a is equal to 1 here, so this is an easy problem. We're looking for something that multiplies to negative 16 but adds to 0. All right, here's a trick for you on these. There is another way of teaching these that's talking about perfect squares, but it's another long list of numbers that I don't want to make you have to memorize. So our factors of 16, 2 times 8, and 4 times 4. All right, so here's the trick. Anytime it's something that's going to add to 0, it has to be a number and then the opposite of itself. All right, 2 and 8 will never get to a 0. 1 and 16 will never add to 0, but 4 and 4 can. We just have to have one positive and one be negative. All right, so positive and a negative, those are our guys. Here's my setup. X and X are blanks, and we just found them. That's a positive 4 and a negative 4. And this would be your final answer. So at least you know whenever you have that 0x involved, it kind of helps you to eliminate lots of factor pairs that are not going to work. We have to find the factor pair that's a number times itself. Okay, let's look at one last example. All right, same thing, 4x squared minus 25. All right, so first thing I'm going to do is replace my missing piece, so that way I am in standard form. Okay, we got that 0x happening in here. All right, business as usual. A is greater than 1, so we're going to have to work a little bit harder. A times C is negative 100, and my B value is 0. Again, you can list out all of your factors, but remember we're looking for the one that has matching numbers. 5 times 20, 6, 7, 8, 9, and then we got our 10 times 10. Ding, ding, ding. We got to have one be positive and one be negative, and those are going to be our guys. So here's my initial setup. Minus 25. And these are the two blanks that we're trying to figure out, our missing pieces. So we just found those missing pieces. One was a positive 10x and the other is a negative 10x. Alright, so remember in this step what we're doing is replacing B. Before he was 0x, he was a 10x and a negative 10x. From here I'm going to factor out my GCF. My GCF in my first group is going to be a 2 and an x, so I divide out that 2x, and I see what I'm left over with on the insides. 4x squared divided by 2x is 2x, and 10x divided by 2x is a positive 5. My GCF in the second group is going to be a negative 5. Okay, hopefully you recognize that was 5, but since my leading term is negative, it has to be a negative 5. Negative 10x divided by negative 5 is positive 2x. Negative 25 divided by negative 5 is positive 5. Checkpoint. Do you have matching parentheses? Are they hashtag twinning? In which case they are. Alright, so we take what's left over on the outsides. 2x and a negative 5 becomes the factor. And then one of our twins becomes the other factor. 2x plus 5. Alright. And that's it. So remember, not every single problem will not be in standard form. Hopefully most of them will be in standard form. Second thing is, not every single problem will have a GCF. We just have to check for those things. So for example, the first thing on your practice, I forgot to talk about this one to everybody else. Okay, so here too, we are not allowed to have a leading term as a negative. So what we would do first is we would factor out the negative 1 here. Squared plus 5x plus 2 by dividing everything by negative 1 or just reversing the signs of everything. And then we do business as usual too. So again, remembering that we are not allowed to have our leading term as a negative. Okay, so then we would factor this thing as usual. Now looking at this thing, factoring it as usual, I do not have a GCF here. So I'm not going to worry about a GCF. I'm just going to do this business as usual. And one more time, especially if you see something like this. Okay, there is not a GCF here. If your only GCF is a positive one, we're not going to worry about factoring out that positive one. We're only looking for a GCF that's either a negative one or something that is greater than 1. Alright, if you have any other questions, holler at your favorite teacher.